and maybe good morning or afternoon to people in different time zone. So today we have another interesting session. We've got someone all the way from the US of A, and his name is Serg Masís. I'm going to talk a bit more about what makes him unique. He's an author. He's been in this space for long, and he's one of the few people who's got a large following. So he's got a huge body of work. I'll share also his LinkedIn and his email, not email, his website. So he's got a website that's got a whole collection of interesting things. So today he's going to take us on introduction to interpretable machine learning. And if you ask me, the advantage that you will get from being in this live session is you get to ask him questions. He's someone who has been in the space for over 2 decades. So let me just run through the other intro stuff, then I'll talk more about him. So this session is brought to you by your business and MHS Analytics. And we've been running this for the past 4 years. So your business is a training and consulting company based in Nigeria. So which means, you're in Nigeria, you need training in data analysis, Power BI, financial modeling. We are one of your very good options. And MHS Analytics, this that is showing currently is our free and paid resource tool. Maybe I'll share it so you can take advantage of the free templates and resources and exam preparation for those who are trying to take certification exams. And MHS Analytics are not American, actually based in Canada. Same line of business, but just separate audience. So provide the same services, but to North American and European clientele. So in case you've got friends, colleagues, that's the better one to reach out to, then yes. All right. So we have today Serg. And Serg is, apologies if you hear my daughter's noise. She's now very screamy. She's 2 years old. Her voice is gone loud.
Yeah, I know, that's fine. I have a newborn, so probably mine is louder.
So Serg is someone who's got more than 2 decades experience in this data analysis space, and not analysis per se, but much more in the ML data science side. And you will gain a lot from him because of his perfect blend of the theoretical and the I wanted to say practical, but much more the application of all of these within companies. He works for a very large company as the head of the data science, is a lead data scientist at Syngenta, and he's founded a startup, a search engine startup before. So he's someone who's been on all sides. He's written a book. So it's the perfect mix that we are looking to. We are very fortunate to have, and so I'm going to go out of his way and let him take the session. I'm going to share his About Me link and his LinkedIn too, so you can get to know more about him. But at this point, it's better I hand over to him. I've taken more than the usual 1 minute. So, Serg, over to you, and it's a pleasure to have you. Thank you.
It's a pleasure to be here. Thank you, everybody, for joining. It's exciting to be speaking to people in Nigeria. Hear a lot of good things about data space over there. And Africa in general, but I know Nigeria is one of the hotspots. Very, very promising future. So let me share my screen. There's nothing there at the moment, but set this up. All right.
Yeah.
So the presentation is called "What Do Planes and Machine Learning Have in Common?" How explainable AI can improve decision making, and well, for people in analytics in general, like what do we use data for? Ultimately, data and models, our whole line of work is about decision making. It's not really about the data. It's not really about the technologies. It's about making more informed decisions. That's what it is. And so, yeah, there are a lot of aspects behind that, and we're going to get into that. So I'm going to get into the next slide. Well, yeah, as you mentioned, I'm a lead data scientist. I work on food security problems, so I work in a global organization. We have offices all over the world, including Nigeria. And yeah, like I like that space because food is really important. But I didn't always work in food. I worked in web and app development. So I was mostly a developer. So when the two decades experience, they're mostly on that end. They're about getting reports for the websites and that I managed generating reports, doing SQL queries to kind of connect all the different sources together and to if it was an e-commerce site, making sure that the data for the e-commerce site was being registered, things like that, but they were really data facing in that sense. Later on, I actually worked in an industry that was very data intensive, so much so that there was a time in which we had to destroy our data, well, not destroy it, but kind of archive it. And to some extent, you could destroy it after a certain amount of time because there wasn't enough. This is back when the largest hard drives were like 1 GB, right? So not a lot. So I worked in the gambling industry, so sports betting, poker, all these things. So yeah, like that. Making applications for that meant that we had to store a lot of information, and there was a constant stream all the time. Anyway, I've written some books, as you mentioned, and so I'm now on to my fourth book. Yeah, and so I'll just go on from there. So like this is the session is divided in 3 parts. First, a short story, and then I'll explain about explainable AI and interpretable machine learning, and then I'll discuss briefly what's in store for AI. Explainable AI. So I'll start with the story, which bear with me, I'll connect with machine learning interpretation, but it will seem like it has nothing to do with it at the beginning. So this good-looking guy is my grandfather back in 1951. This is a story he likes to tell. And to provide some context, he had been working for a Texas-based contractor for the Pan American Highway construction project as an office errand boy since he was 12. By 1951, about 8 years later, he had ascended to payroll manager. So he was in charge of payroll for a crew of a couple hundred workers that were building what the U.S. Army Corps of Engineers deemed the most treacherous part of the highway in the entire continent. So they stationed him in the town where this portion of the highway would end. And then every 2 weeks, he would have to take the long drive to the city on the other side of the highway that was still in the construction to pick up duffel bags filled with cash to pay the workers. And people were very honest back then, so he was never once robbed at gunpoint or anything like that. But there were other dangers. Avalanches were frequent, especially during the rainy season. So when this would happen, he would fly on a 2-seater propeller plane instead. And this is what one of those planes looked like. My grandfather laughs about this, but these planes have nothing but a latch door, and any amount of wind or rain would make them tumble around like a leaf. And the controls and instrument panel were primitive, to say the least. And they were prone to failure too. And in cloudy conditions, the pilot would just take an educated guess based on the position of the mountain peaks. And when he descended under the clouds, he would see a destination, a valley underneath. This is what he would always expect because, obviously, like the town where he lived and the city were both located in valleys, pretty prominent valleys. So, and sometimes when peaks were not visible, he would just take a random nosedive to see if he was on track, and oops, almost crash into a jungle-covered mountain. My grandfather laughs again, but I'm not all that amused. This happened many, many times. Fortunately, despite many of the close encounters with mountains at the hands of the mostly drunk and kind of reckless pilot, he always managed to arrive safe and sound. I don't think I'd be here to talk about it otherwise. So this is the end of that story. So what does this plain story have to do with machine learning? Well, there's a link between AI and aviation. For millennia, predicting and flying have been the domain of supernatural. You know, nearly like 300 years ago, 200 years ago, if you talked about someone flying, they would say, oh, you know, there's something supernatural about him. He's a god or an angel or you know, there's something like out of the ordinary, out of this world about that person. Or at the same time, predicting, same thing. Someone could tell the future. There's something like kind of like witch-like about this person, you know, like or you know, godlike. So that's something they have in common. Also, recently technology and math have allowed us to do what not long ago was considered magic. So predicting the future, obviously to not like probably to a better degree than a fortune teller would be able to, but you know, still not at the 100% certainty. And of course, planes. We have engines that can, you know, they have 11,000 horsepower like this one, you know, and this is a Google TPU that can do trillions of multiplications per second. Okay, AI and aviation, you know, like they also have a few things in common. Aviation began with none or few regulations, reckless pilots, and many accidents. You know, like the pilot in my grandfather's story, we could all agree he's reckless. Well, he also didn't have the best instruments, but we'll talk about that in a bit. And then AI has also begun with none or few regulations, reckless pilots, and many accidents. However, aviation is today the safest transportation method. How was this possible? Strict regulation by national and international entities, standardization of parts, methodologies, and quality control, rigorous training of pilots with civilian passengers in mind, and more robust equipment. And of course, more and better instruments. And then AI can become the safest decision-making method. How can we make this possible? Strict regulation by national and international entities, standardization of parts, methodology, quality control, rigorous training of pilots. And when I say pilots, we talk about machine learning engineers, data scientists, and so forth, with civilian passengers in mind. And of course, when I talk passengers, I talk people that are using our machine learning models. More robust equipment, of course, and more and better instruments. So this begs the question, what would be an instrument for AI? So those don't know, what we call artificial intelligence is really produced in the dumbest possible way. It's like code that looks somewhat like this. And of course, this is a very toy example, but it's not too much different than training the latest large language model, except you're using probably more powerful equipment. And so you hit enter here, and then this happens. You know, it goes through several like iterations, trying to achieve a better accuracy or whatever metric you're trying to improve. And you know, and it's dumb because it's a single metric, it's a single goal. So it's like using the plane just okay, based on a direction and you know, not maybe speed, but the altimeter. So you're measuring how high it is and how low it is. So those are like, if those are like the only instruments you're using, it's going to be really tough for you to operate under other conditions. So it's like the plane. In my grandfather's story, if you have few instruments, you know, it's only good to operate when the day isn't cloudy. But when the conditions are bad, you know, it could be dangerous. And the same happens with data. data has good conditions and bad conditions. The good conditions are the ones, the ideal ones, the ones closest to when the data that was trained for that model. And the bad conditions are the ones that are unforeseen territory, data that's very different to the training data that was used to train the model. So that's equivalent there. So when it comes to machine learning, you know, this on the left, we have the two-seater propeller plane on my grandfather's story. And you have a surprisingly low amount of instruments. And that's like usually how machine learning is trained. And then, but to make models that are always reliable and safe, we need to use as many instruments as possible. So something closer to what we have on the right. So what is interpretable machine learning and explainable AI? In a nutshell, explainable AI is a collection of instruments that we can use to pilot AI, ensuring trustworthy machine learning models. First thing to know about these terms is that they're pretty much the same thing. One stems from academia, another more from industry, but they're pretty much used interchangeably. I prefer the term actually interpretable machine learning because it's less, it's more like real. You know, when I tell you I need to interpret something, I'm like telling you I'm not giving you the impression that I have a lot of confidence in it, which is not always the case. But when I tell you I'm something that's explainable, you can brush it off pretty much just by the use of that term as something I can explain. And it kind of also gives you a sense that I have confidence in it. So I prefer interpretable just simply because of the semantics. But however, I'm going to use explainable AI throughout this presentation because it's just you know, probably easier to kind of grasp. And it's also become the most increasingly popular over the last 5 years, as evidenced by the Google Trends. So although relatively new in public domains, these terms have been long present in academic literature. And likewise, during the same period, there has more and more mentions in books by both terms. However, the vast majority of these books have been either non-technical for a business audience, books about AI ethics, or academic compilations. Practitioner-oriented books on the subject can be scarce all these years. And my book, you know, that's now on the second edition, that's an old image, but it looks more like this, was published in 2021, and the second edition in 2023, so last year. So by now, ever since I published my first book, there's been well over a dozen books on the topic, thankfully. But my book was only like the second one on the subject. That was meant for practitioners, that is. So what exactly is interpretable machine learning? We know it's instruments. What kind of instruments? What can they do for us? So first we have to understand the concepts. They are fairness, accountability, or transparency, or FAT, which means you expect the machine learning model to produce fair predictions. They must be robust and traceable back to something or someone, and you should be able to understand how they were made. So there are many concerns associated with these concepts grounded in ethics. And ultimately what we want to know is can we trust the model? Because trust is mission critical. So we have nothing and we don't have trust. And that applies to any technology. If you can't trust the technology, you won't use it. And you know, technologies, you know, they become tools. They become tools that are like, in the best case scenario, they're just like seamless. We forget they even exist because we use them all the time. It's not a nuisance. They become part of our life, part of our lifestyle. That's what they become. And for that to happen, we have to trust them. So does interpretable machine learning equal ethical AI? Not really, but both concepts overlap. Ethical AI, also known as responsible machine learning or responsible AI, encompass much more than interpretable machine learning because it includes data and algorithmic governance aspects. These aspects include privacy regulations, data management procedures, and even modeling standards. They also hold, you know, fairness, accountability, and transparency. On the other hand, interpretable machine learning is how we can implement FAT with machine learning. And these tools that can be used for ethical reasons can use with no ethical reasons in mind. In the same way, like the tools that are used to, say, prevent hacking can be used by hackers to hack, right? It's you can't avoid that. And also, well, yeah. Also, the other thing is you pretty much, another way I like to explain interpretable machine learning or ethical AI is not even from an ethics standpoint. It's from a quality assurance standpoint, because that's what trust is all about. You know, like you only trust the technology if it embodies quality, if it embodies something you know that you can actually rely on. And so that's why trust is mission critical. So we have to ask ourselves, when we say trust is mission critical, what is the mission of AI? And as I said earlier at the beginning of the presentation, like that's what data is for. Data is to improve decision making. But AI goes a step further to enhance or replace human decision making, because there's an aspect about automation that AI that descriptive analytics like business intelligence won't do. Because a business intelligence use case, you take the data, you interpret it, and you make it, someone else makes a decision with it. So that's what happens in business intelligence. With AI, it becomes even more important because there's some automation. And so there are tall orders here, but hopefully not in a bad way. And so that's why we have to evaluate both options. And so what both options I'm discussing here are about human versus model decision making. On one hand, we have a human that carefully takes all these many steps to make a decision, right? We go through all these 7 steps, every decision we make. No, I mean, actually, this is what Nobel laureate Daniel Kahneman calls system 2 thinking. System 1 is usually what we do, and so it's fast thinking, and it's very biased, and it can often lead to unfair decisions. Which is why when people say, are you going to really let AI make these judgments or not? Say, well, it's probably better than a human judge. Like if you were to replace human judges at courts with an AI, I can't say for sure that the AI would be worse. Because sometimes in many courts, like a human judge only has like 10 seconds to make a decision, 20 seconds. They barely glance at the file and they're already making a decision. So, and if they're tired, they're going to be making a worse decision. So, like it's not necessarily better, but it's still something we have to consider. So, on the other hand, we have the model. And the model, when people discuss the model, they think the machine learning's model decisions are its predictions. And that's the very last step. That's inference. So when it's being used in real world applications and we're asking a question, that's inference. And that's where you think the decisions are, but there's many decisions that were made before that by a human. And there's potential for bias in every prior step. What part of the problem to focus on, what data to use, and the bias that data carry, how to prepare the data, what model classes to use, what evaluation metrics to use, and how to deploy the model. There are many intraceable decisions that were made before and not communicated or even understood, create an accountability gap that lead to unfair outcomes. So to sum these things up, both the model and human decision-making are complex and generally opaque. Both have their strengths. We can complement when we use to our advantage. So it begs the question, we have this accountability gap. How do we close it? How do we make things better? How do we leverage the best we can both offer? Like humans can do flow thinking or system 2 thinking. Models are good at automating those things if we actually put in the work to embed the best kind of decision making we can make into the model. So that means the way we model things cannot be lazy. It can't be just throw the data, at the model will figure it out. No, that's where we have to go through a workflow where we're using all our instruments. So I'll show you a few of those instruments. So one of those instruments is called global interpretation. And in particular, this one is called feature importance, and it's a form of global interpretation. And so global interpretation is any kind of interpretation methods that looks to understand general aspects about all the predictions or functioning of a model. And the good thing about this method is you can organize all the variables to see which ones were most important to the model and how. And this one in particular has that possibility. It can show you in the same chart, it can show you both things. It can show you not only the importance of a variable, but how it correlates. So you do the highest feature values of this variable correlate with a certain kind of outcome, or do the lowest ones. I'll give you an example. This is for loan applications. So it's clearly saying, because of what you see here with this red over here, that the high values of payments correlate negatively with the possibility that someone defaults on the loan versus the low total payment. So this is what we call a monotonic relationship. So when you see in any kind of chart that you have one variable on the x-axis, another on the y-axis, and you see like a line consistently going in one direction or another, you can establish that there's a monotonic relationship between those two variables. As one increases, the other one decreases. As one increases, the other one increases, and so forth. So that's what I speak of when I say monotonic relationship. And evidence of that is this gradient you see here, because it's almost a pretty smooth gradient between the two colors. So like there's a lot of things you can grasp from them. I'm not going to go through everything, but feature importance can help you understand if the model is making the predictions for the right reasons. Because something that's missed out when we look at metrics like accuracy and everything, you miss out on the possibility that, hey, maybe the model is making the decision for the wrong reasons. Maybe it's confused with something else. Maybe I have something called data leakage, and that means like I'm including a variable that pretty much explains the outcome in my model, and it shouldn't be there. So there's another kind of interpretation method. It's called local interpretation, and we're going to look at something called saliency maps. So there's many ways I can use saliency maps. I can use them in computer vision models. So this would be a model that is trying to find out if this is a dog. And then this one is one that's maybe looking at sentiment analysis. So it's figuring out what words are negative and which ones are positive, to come up with an idea the total paragraph, be it a review or something, is positive or negative. So with this one in particular, it shows up as a heat map. So you can see which pixels are what determines this is a dog. And it makes kind of sense. If you were looking at this image, what tells you it's a dog? It's a combination of the nose, the eyes, the mouth. Those are like the most important things that tell you it's a dog and not something else. And this is important to look at because, as I was saying before, sometimes a model can be wrong, right for the wrong reasons. So let's say this was let's say you had a sheep farm, and you have to classify the animals on your sheep farm. So you have the dogs, which are herding your sheep, and you have the sheep, and you have to also classify potential threats. So say you have images of wolves. So a wolf and a dog has similarities, but they're not exactly the same. What if you realize it's detecting wolves accurately according to the model, but then once you use it in real life, it's like, oh, no, it's not. And then you realize the reason, and this has come from a famous example, the reason they figured out that a wolf was not because of the wolf, but because all the images you had of wolves were in snow. So it's pretty much only what it's detecting in the image is snow. Anytime it sees snow, it's a wolf. Anytime it doesn't see snow, it's not a wolf. So that's kind of a wrong reason to be detecting a wolf. So a well-performing model is going to be looking at the canine teeth, which are like and maybe the eyes, the shape of the eyes, and other elements, and the pointiness of the ears. That's what's going to be saying, oh, that's a wolf and not a dog. Those are the elements that make a wolf more menacing than a dog. So I went down the tangent there, but the important thing is saliency maps can help you understand what is the essence behind the decision, and it becomes really important when you're trying to operate something completely automatically. Be it in your sheep farm, you're trying to set up an alarm system that tells the humans on the property, hey, there's a wolf around, or maybe there isn't such a urgency with a review system, but there definitely is with self-driving cars. So that's when we have to kind of look and figure out, is the reason it thinks this is a person crossing the street the right reason? It could not. Maybe it's not a person. Maybe it's something that is confusing the model. Maybe it's like a cardboard box that has an image of a person. So that's what we have to look at. What are adversarial attacks? Like, say someone was crossing the street with a cardboard box of a person, and you trick the model into thinking that's a person. Maybe that's not such a terrible thing, because if the cardboard box is not moving itself across the street, maybe there is a person moving it, right? But in some cases, it could be pretty bad. It could have caused an accident. In some cases, it's even malicious. People are doing that on purpose. And whether you're aware or not, the difference between a good classification by a model and a bad classification is something that may be imperceptible to you. Like this 0.5% of noise. You take this noise and say you put it like very, very faint layer of it. 0.5% of this noise on this image, it stops being a pig and starts being a plane. So how do you turn a pig into a plane? For the model, it's this simple. For a human, you look at that and say, no, it's not a plane, it's a pig. It seems almost ridiculous, but that's how these systems work. So there's a whole area of interpretable machine learning, explainable AI, that's called adversarial robustness. And it's about making sure that the models are robust to this kind of attack. Another aspect is privacy preserving machine learning, and what happens when you have to preserve privacy of machine learning models. It means that we have to take things that are identifiable, information for people. In other words, like fingerprints. They could be biometrics. They could be conversations that are private. They could be medical records, and we have to crypt them in such a way where they retain the correlation properties. You can still train a model on them, but to anybody looking at them, we can't understand them. So there are many methods that are like that can preserve privacy on different levels, and there are good reason to do that, including adversarial robustness, because adversaries will want to steal data as well. And then last but not least, there's the question of mitigating bias. Something that happens a lot in machine learning, and it's not machine learning's fault, is the data that is biased. And it's not something that's as evident in the business intelligence, descriptive analytics world, but it certainly is in the machine learning world, because our orders are to kind of automate things, not to kind of and also the granularity of what we're doing is far smaller. You know, we're not giving like a general like description of, you know, what were the sales over the last few months and what is the trend, but we're predicting things at a far more granular level, and so that can lead to figuring out, okay, this model is biased. This whole kind of system is biased. So the problem is not the models. It really starts with the data, and so we can do all sorts of things to figure out how do we undo this. You know, sometimes it's not about the model reflecting the data accurately. It's sometimes not the model that predicts the future, the past. We don't want a model that predicts the, you know, based entirely on the past sometimes, but we want a model that predicts the future based on what we want from the future. So we have to kind of think in those terms often, just to avoid bias. Another thing that's kind of tricky is sometimes bias is just intrinsic to the way we communicate. And that's the case with, you know, language. Unfortunately, you know, like say we're translating from one language that uses, you know, gendered pronouns and one that doesn't. We'll end up with all kinds of situations where it's going to have to assume what gender it is, because in a language that lacks gendered pronouns, it's not an issue. You know, when you're talking about a doctor, it could be a male or a female doctor. It's not going to matter. But when you're translating into another language that has it, then it's all of a sudden a big issue. Another thing is when you ask a question to a large language model, and it has to generate an answer based on that kind of refers to the pronoun of a gender, or refers to the ethnicity, you know, makes an assumption of an ethnicity or some other kind of you know, sexual orientation or anything like that. It might have to make an assumption, and those can be pretty troubling. You know, assuming that all doctors are men and all secretaries are female, like it is here, or assuming things like that can be pretty damaging. So we have to figure out ways to mitigate these things, and those methods do exist, and that's part of the tool set as well. Because when we're speaking about making an explainable model, like the explanation is just like the base level, just making explanations. It means you also may have to make it consistent, robust, fair. Like there's a whole other set of properties that do matter, so that it is trustworthy, because that's the ultimate goal. You want a model that's trustworthy. So lastly, I'm going to go through this fairly quickly. What's in store for AI? So we got the pilot, the plane, and the regulatory framework. When we talk about the pilot, we're pretty much talking about machine learning engineers. And so this is what they say we generally need, okay, to have. So the way it goes is we have programming skills, and that's usually like something that is unfortunately like a requirement. We have domain expertise, which pretty much anybody that works in the same business we do has at the same level or higher level. And then we have some statistical knowledge. And so like the idea is we get some intuition from our domain expertise, we validate it with our statistics, and then we automate it with our programming. And at the end, the data sciencey part comes with an insight. You know, so that's kind of the way it works. But in the future, I think no programming skills, no problem, because I think that's the biggest like issue with getting more people on board. And I think it's important to get more people on board, because I think it cuts away from the possibility of people that are very knowledgeable, that have worked, say, in the business for a long time, to come in and to develop their own models that are probably perform way better than someone that whose biggest like contribution is programming and statistics. So that's why in the future, I think what skills will be required? An expertise in a machine learning UI-based tool. So kind of a drag and drop situation. Is still, I think statistics are important, but I think probably depending on how good those UI-based tools are, it might be able to warn the person of things that don't make sense from a statistical standpoint. Because probably what matters most is not like the statistical issues. What matters the most is that it is intuitive from a business standpoint, that the variables that they're connecting correlate. Well, they don't just correlate. There's a causal relationship between them. And only someone that works in the company would know that. And that's why I had statistical and causal inference, right? And that's why I think the future is going to be more multidisciplinary. And the present is mostly a manual operation. And the future is going to be more automatic. But by no means, I think, we're taking a pilot out of the plane. I think autopilot is there, but there's always a highly trained pilot inside. Another problem is with the planes is garbage in, garbage out. And you've heard this a lot. Data is the fuel of AI. And this is not to put down people that work in descriptive analytics, by no means, but it's a lot harder. I mean, what I find in my company and a lot of companies I work by, I tell people, I tell executives, we have a data problem. Our data is crap, and they say, you know, they're puzzled because, you know, they have business analysts, they have, you know, in my case, they have agronomists, they have other people that told them, oh, this data is good. But the difference is what you're using the data for. So if you're using the data, like I said earlier, for sales trends, and all you need are like the averages to more or less make sense, the sums to make sense, but not on a granular level, each individual sale, then descriptive analytics is not going to have a problem with crappy data. But predictive analytics is, because each data point matters for predictive analytics, every single one. So a single problem is an impurity can throw it off. So if you take crappy fuel, you know, with all these impurities and you put it in a jetliner, you're going to find yourself into trouble. So that's where I say there's a difference. You know, like descriptive analytics is more like driving a car, and predictive analytics more like a plane. Because we're going into unforeseen territory, and we have a more stringent requirement on the fuel we're using. The plane, present is code driven. Everything's code. And as I said earlier, in the future, UI driven. And I think that's for the best, because that's going to allow us to use more tools, more instruments, and to use them more effectively. And so that's where that. As for the regulatory framework, right now it's mostly vague. It's strategies and plan. And some laws, mostly in Europe. Including GDPR, which mostly focuses on privacy and data governance. Unfortunately, it doesn't go into a lot of these things involving interpretation of models. And then in the future, I expect AI auditors, lawyers, and blockchains to be involved as well. So that's pretty much, it's kind of an abrupt ending, but that's the end of the presentation. And I hope you guys enjoyed it, and let me know if you have any questions.
Thank you very much. There are questions, so I'm going to read them. I don't know if you see the chat too, but they are mostly in the chat, so I'm going to also I can read them to you.
Let me see if I can see the chat. Yeah, I just was able to open them.
Oh, okay. So, all right. So maybe I'll read them so that at least it makes it a bit more interesting than you just reading and answering. So I'll start with the first one. All right. So where does the current generative AI tools largely fall? So this is where you are showing the ethical AI and interpretable AI, like circles intersecting. So where do you think they largely fall, the generative
Well,
AI?
I think there's a misunderstanding there. I don't think I was claiming them to be categories. They're mostly like terms that use for the same concept, except like ethical AI kind of encompasses more like administrative things that are not applied technically through code or like systems. Uh, so like I think generative AI, there are probably people working on both sides. There are AI ethicists that are looking. They're not usually AI ethicists are not technical. Well, they're not programmers. They don't actually. They're not practitioners, but they're maybe philosophers, sociologists, and whatnot. And those people are analyzing large language models from their angle on the impact they have on society, on what kind of things they find that they're outraged about, and discussing it with communities and so forth. Uh, so I think generative AI has sparked debate with the ethical AI community, but on the interpretable machine learning side, I'd be completely surprised if a company like OpenAI is not using interpretation tools in-house to interpret their large language models. It is tough. I've tried it with even much smaller models, and it is very tough because the larger the model, the more complicated it is to interpret it. So it's massive, like if the large language models would be planes, they wouldn't even be planes, they would be blimps, like they'd be like too big. But the thing is, in-house, I know a lot of people probably do that. I don't see people outside of that. Like I've taken like a 3 billion parameter llama model and interpreted it. That's as far as I've gone. And I can do it because when you think about it, like a large language model, and that's just an example of a generative AI tool, because we also have diffusion models, and that's a whole other can of worms, DALL-E and all those. But a large language model at its core, it's just a model that predicts the next word. So if you're interpreting that, its ability to predict the next word and why it's predicting the next word, you can use the techniques that we use in interpretable AI to do that. Where it gets tricky is when it's already kind of producing big responses. Then you have to interpret the whole thing that it's doing and try to figure out why it's doing that. So there's different ways of getting through that. You can figure out where the training data came from. So you have this massive corpus and you're trying to connect it to that data. So there are all kinds of tools that already exist to do these sort of things, but it depends what your use case is. And so, yeah, to answer the question in short, there are elements, it falls in both. It depends who's doing the interpreting. Is it a AI ethicist or is it a practitioner of machine learning?
Okay, I think I get it now. Okay, thanks. So the question next to that is, in traditional companies, what level of AI is now ingrained in their processes and well accepted? The part where you made this analogy of that at some point, the technology becomes tools that we don't even think of the technology anymore, but we see the tool and forget that there is that technology beneath it. So do you already see do you see in companies a level of AI that is so ingrained that they accepted it? Okay.
Especially in like the most basic of processes. It used to be that there was more friction. Like for instance, like say you had a customer service team and you introduced a new tool that had AI in it. It was pretty, like maybe 5 years ago or even more. It was so primitive that the customer service agents would be, no, I don't want to use this tool. It's just, I'd rather do it myself. It's just not giving me the responses I need, right? Like be it like something that would draft a response for a customer automatically, or something that engaged with the customer automatically when they first called in, things like that. Those tools weren't good enough, but now they're so good, like the customer service agents forget they exist. It's almost like part of their work. It's just, okay, I'll just have it draft this email. Okay, change these few words, send it. You know, it's taken for granted. And that's what we want from these technologies. We want them to be taken for granted. The tricky part is where they have to think about them a second chance. So whenever we develop one of these systems, we have to make sure that the human psychology behind the end user, will the end user be too lazy and not check things twice before sending them? You know, because sometimes you want them to do that. How do we not only reduce the friction, but increase, you know, the quality of what's being sent out? Because if you have a human in the loop, that's what you want. You want both the AI and the human to collaborate. The human can do what the human does best at doing, and the AI can do what the AI is best at doing. But if only one is doing their work, then it's going to be crappy. It's like when you have all these high schoolers have ChatGPT make their homework, it's crap. But if a high schooler is smart, they're going to have ChatGPT do a draft, and then they just change it, and then it's good. You know, the teacher doesn't even know.
That's true. Okay, I think you've touched on the question next, but I'm going to read it. So do you think AI and ML tools can replace middle managers whom upper management already hold responsible for their output, versus an AI tool that does not have 100% accuracy? There is no built-in way for it to take responsibility for its own output. So, and then some context, more like the aviation analogy you gave, how it's changed from your grandpa's time to now. And if you think about it, like more roles have been created, there are more people in aviation than, 50, 60, 70 years ago. And like you've also said, the technology has gone, astronomically to a level that, was not 50, 70 years ago. So the question is, can AI replace people? Not people at the lower level, but people at maybe middle managers, people with...
Definitely. Yeah, I think it's going to be a mix. It's going to replace people at all levels, except for the CEO, of course, and the other, high, upper echelons. It's not going to replace them, but yeah, it's going to also replace people in the middle. And the reason is, like, if their job is simply to orchestrate people's time or to supervise certain work that is already kind of being supervised on its own, there's really no point in having them.
What about roles that involve like strategic decision making and targets?
Yeah, those you'll still need those. Those are even at a higher level. In fact, those might even multiply as productivity increases, and you see like companies, they'll get greedy and they realize, okay, well, we can start doing this and this, and how do we strategize these? They'll need people for that. So like the company might become a pyramid, an inverted pyramid, with more people on the top and less people on the bottom. Because even though we expect a lot of people on the bottom to be replaced, when you think about it, it's less and less. Like say you go to a hamburger place, if you've replaced everybody that does the fries and the hamburgers and all these things with machines, what are you left with? You're just left with, it's completely inverted triangle. You'll have maybe one person supervising the robots and like two people, attending customers, and then three people thinking about the strategy of the restaurant.
Okay,
because you're going to want to figure out how to set up campaigns to make the most money, right? And what robots should we get next? What kind of innovation, we can drive this growth,
Great, thanks. So I think one more question, and in case anyone in the house also has questions that are different from the one already asked, you can raise your hand or you can type in the chat and I'll read your question. Okay, so the last question I already have in the chat is, so most companies have consulted or worked for, they are always struggling to get their business processes and major decisions integrated with data science. Sometimes it's because the business leaders view data science models as black boxes that they don't want to take ownership of its outcome, especially when they have targets and responsibilities that they want to fully influence the achievement of without being sidetracked by tools that it can't explain or they can't tweak or they can't fully understand. So I think this is similar to the one you answered. Do you have examples of great integration of AI with upper management? Okay, maybe this is more to like with upper management, where upper management are now so comfy using, a new AI tool to drive their processes beyond the this is outside of the usual IoT telemetrics and optimization stuff that we know everybody agrees that technology are great for showing where everybody is or tools are or stuff. But beyond that, supply chain operations optimization and IoT visibility, are there other ways you've seen upper management, fully take advantage of AI to influence their high level decisions?
Yeah. Um, yeah, there's a lot of instances where you could apply AI to improve processes. They don't even have to be real-time processes. Um, and they could maybe it's influencing marketing, how much they're spending on specific campaigns, and it requires them to trust the system. But the system has to be built in such a way it's explaining things. So I think that's part of the problem as well. Also, managers have their own biases. Managers want to impress their managers, and their manager might want to impress the CTO. And one of the problems with a data-driven approach, and even a machine learning, and to more extent the machine learning or statistic-based approach, is that it's not it's not meant to be a strict value. Like when I'm predicting, I'm doing a sales forecast for the next month. You know, I know what my boss would like to hear. It's increasing, and I don't know, maybe by 10% or 20 or 30. Woo, but that might not be realistic. What can the machine learning model do for me? It might tell me, yes, it's gonna increase 5%. Maybe not that impressive, but a good machine learning model will give me a range and tell me, well, it could happen that it's decreasing 5%, and it could happen that it's increasing 15%. But somewhere in the middle is the 5%. That's what we're targeting. But no manager wants to hear that. They don't want to hear uncertainty. They hate uncertainty. But that's the reality. We live in an uncertain world. So it's really hard to fight against that culture, and you're going to find a lot of things once you get really data sciencey, you know, because that's one of the things, like in the business intelligence world and in the descriptive analytics world, it's very easy to gloss over. You show them these charts and say, oh, look, this is a trend, it's increasing. And they're like, yeah, it's increasing, and everybody applauds and they're happy about it. Say next month is a lower sales month, they're going to be disappointed and say, what happened? The trend said it was increasing. But had they handed over this to a machine learning model or even to a simple statistical model by a statistician, they would have found that there's uncertainty there and said, okay, these are the bounds, and they wouldn't be disappointed. But then you have to kind of break that culture. You have to say, if we're going to be data driven, we have to embrace uncertainty. We have to let go of our biases and let the data take over of what the data is best at doing. And so that doesn't mean everything, but it certainly means these parts of it. Take out the guesswork, and come up with something that doesn't necessarily like mask over the uncertainty that really does exist, and the biases and all these other things that do exist in the data and the world, but kind of embraces them and makes them part of what we do, because that's what we're there for. We're there to inform the company. We're there to give them direction. And yeah, I certainly think that incorporating the data science workflow in there is a struggle because of culture. And then taking ownership of the outcome is a lot easier if you're managing expectations. So I applaud the manager that is brave enough to tell his boss, we have this range. It could be bad next month. It could be great. And we're somewhere in between, you know?
Yeah, thanks. I know we've used the time, and do you have maybe 5 more minutes? I see people are saying thanks. Okay, great. So there is always two questions we ask, people like you who's got this breadth of experience, and we find out that beyond just the technical knowledge we gain from experts like you, it's also the journey. So two questions, I'll ask them together, but usually they are separate questions. It's because I don't know how much minutes you have to spare with us. So question one is how you started your journey, how you started from, not anywhere near this field. It could be, I don't know, maybe before you, but anyway, when you were like at a zero level, when you didn't even know if this was what you will end up being in terms of profession. So how you started from then to here, it's always nice to hear people's journey. And then the second question is your advice to people who are at the beginning phase or are trying to figure out a roadmap to becoming, professionals that are adding value in the corporate space. So question one is your journey. Question two is your advice and kind of a guide that people can take today.
Okay. Well, my journey is very long. It's not really wasn't my choice to do it that way. It just happened. Like in the sense that I didn't realize. I mean, when I went to study computer science, the reason I wanted computer science was because anything I like to do, I like to do through a computer. If I was going to do artwork, I do it through a computer because I can't draw, but I can certainly use Photoshop and all these other tools. So, I mean, that's if I was gonna, and that's an avenue I was exploring. I was exploring special effects and game design and all these other things because I like that stuff. The other avenue I was exploring was web development, but because I liked, web, I liked the fact that, we were connecting the world and there was all this information and that was beautiful to me. So I liked that. And then on the other hand, I did like data. I liked Excel, but it wasn't exciting enough back then because there wasn't that much data, even in Excel, and it was slow and clunky and everything. So we're talking over 20 years ago. So I didn't think of that as a viable area. Like, so I ended up going through websites. I didn't see special effects as viable either because I lived so disconnected from, Hollywood. Just thinking I would end up there was just almost impossible. So I thought, okay, I'm going to do with the website things. And then the websites kind of drew me back into the data world eventually, I mean, of course, from the first website I was making or the second one, I was already dealing with data at a small scale. And then eventually SQL, Oracle, all these other databases. Eventually, I was using business intelligence tools. I didn't call myself a business intelligence person, but I was wearing the hat, like if someone wanted a report, they would come to me, right? So I did not, it kind of happened slowly. And then what eventually happened is that I just got fed up with development. I get fed up with dealing. I became a manager of my team, and I set up all these systems for bug requests and for projects and so forth. And all the people working for me would do those projects. There was a bug in a website or there was something not functioning in some tool, they would handle it. And I would train them how to do that. But I didn't want to deal with that. But if the marketing manager wanted to figure out why, his campaign, what kind of customers were coming in because the systems didn't connect and they wanted something like that, I'd be like, I want to do that. I put that project on me, right? I wanted to deal with the data because I realized that was the answer to everything. If I was close to the data, if I was doing the data, I knew what direction to take my department, how to make the websites, how to make the products go in the best direction. You know, and then I could, in the next meeting with my boss, I could tell him, you know, like, I have all these ideas and they're formed, but what our customers want, and this is how I know why, right? So that's where I started to go in that direction. Sooner or later, I realized data was like the girl next door, you know, like my first true love, and I didn't even know, you know, like it just came back in my life. And eventually, I just had to marry her. So that's how everything happened with data. And my advice to people, if they're starting out in this field, is if they already know, because the way it happened with me is just that data wasn't viable. It wasn't a career when I started, but now it is. If you know that it is, start moving in that direction. And the way to start moving in the direction is first through exploration. Exploration first. You don't have to get every book and learn about absolutely for everything first. No, first it's a question of finding the things that you have passion for. If you have passion for I don't know, like geophysics, right? And you like the petroleum industry, which I know is big in Nigeria, and you like everything involving that, and then start learning about those things, data sets involving that, people that work there, ask them advice and things like that. If your thing is, maybe it's entertainment, and you want to figure out how to incorporate data insights into, film, then meet people that work in Nollywood and have all those insights that you could use, all that data, and maybe you can create a predictive model that can tell them what is the next, blockbuster they should film, and this is why, right? And it's something you can maybe sell. It can become or maybe it's something you could learn. You're passionate about sports, so start getting, maybe your favorite team is, I don't know, Manchester United, and you really follow the Premier League. So start gathering statistics for them and figure out how can you learn from it. It doesn't even have to be predictive at the beginning. It doesn't. That's the big thing people misunderstand about data science is it's all about machine learning models. No, it starts out like every other data project. It starts out more like closer to business intelligence than anything else. Once you understand that and you realize that your project has to be machine learning, that's the only way to solve it, then that's where you go down that route. But the idea is to start simple and become more complicated over time. And I think the best progression in any career is to do that. Start with simple, learn the foundations, the building blocks, embed yourself in the what you're passionate about. And if you already work in the industry you want to work in, say you work in telecom and you love telecom and you know so much about telecom, you can start applying that. Just get data sets involving telecom, figure out, okay, well, I want to figure out how to optimize like telecommunications networks, So you start learning about graphs. You start learning about how about I learn about graph neural networks, and then you go on from there.
Thanks. Thank you very, very much. I can see a lot of people are even, expressing their thanks. We've gained a lot from you. It's been slightly different from most of the other sessions we've been having. So it's a good one that we are getting this, this idea, this aspect of interpretative AI and things that are much more closer to the application side of things. And all your experience that you've shared now is even way more valuable. I see a lot of people. Well, I can't see them, but that was where most of the comments started coming in. Like thank you was while you are sharing your journey and your advice. So thank you very much, and we have come to the end of today's session. And Serg, thank you very, very much for this. informative, educative, and really valuable time you've shared with us and your experience. And we hope that maybe sometime in the future, like maybe, I don't know, maybe we'll let you rest a bit. I know you travel around the world. I was looking on your website and you've got all these sessions in Europe and you're in the US, and seems you really your hands are filled with sessions around the world. But someday in the future, maybe a year or 2 years from now, it will be nice to have you again. And how is your book
I
going?
love it.
Do you think your second book, your current book, do you think it will soon be done? So if it's done, let us know. We will help you announce to the entire community. We've got about 5,000 members, and we can always help you announce your book launch, your current book.
Okay, the current one. I'll share you. I don't know, maybe how you get these books in Nigeria, but I mean this is the next one. It's already like announced. And,
Oh, it's already announced. Okay. Yeah, Amazon is always
and the idea is different.
Oh, okay.
I'm writing it with my brothers, and the idea is it's for people that want to start with AI from zero, ground zero, and apply it at home, with simple things. Like if you have a computer with a camera, that's all you need for a lot of projects.
Wow. Wow. Okay. I can tell people, I see people are asking, how do I get the book? Well, I can tell you for sure that if you go on that link, you can be able to place an order. That's the beautiful thing with Amazon. Amazon ships books to everywhere in the world. So that's an advantage we get with books. I know for electronics, they sometimes don't ship to outside of maybe the particular Amazon country link. But I know for Amazon.com, books go everywhere in the world. I've gotten books in Nigeria by placing order directly at the Amazon.com. And the beautiful thing is the best price is always on the Amazon.com, not the Amazon.uk or Amazon.co.ca or any other one. Amazon.com, the US one, always has the best price for a book. So I'll say the link that Serg has shared. That's your surest way of getting the best price. And if you use Kindle, let me check. I think do you have the Kindle version too?
It probably will have a Kindle version.
Okay, but yeah, so if you use Kindle, all the faster, you don't have to wait for shipping. You just buy it and it instantly syncs to your Kindle. So what's the book name? I will post it, but the link is already there in the chat. And there's one more.
That's the one that's yet unreleased, and the ones that currently released is this one. It's a second edition. It's this book over here, and it's the talk is about this topic, the talk we just had. So yeah. It's a lot closer to what I was talking about.
Yeah, Serg, you're saying something, right?
No, I didn't say anything.
Oh, okay. All right. So thanks. And so to everyone, Adewale, Cynthia, yes, the links you shared is your surest way of getting it at the best price, because that's how I get my books. And I can tell you it will always be cheaper than another route. So thank you very much to everyone. And we hope to see you next week. It's a weekly session. And to Serg, our special guest, thank you for the time. You've given us 17 more minutes. So it's like we've taken 1 hour, 30 minutes of your Sunday. And thank you very much. Apologies, we've taken you away from other important things, but we learned a lot. We're grateful. Thanks. And bye to everyone. Have a wonderful week, everyone. Bye.
You too.